Okay, last little bit we kind of have to talk about. And we have talked about this already, but this is just putting it together formally. We're going to talk about first differences. Now that's something that came out of your grade 9 unit. First differences are the differences between the y values that correspond to consecutive x values. In grade 9, it was the rate of change. It gave you your rate triangle. A linear relation has constant first differences, whereas a quadratic relation has constant second differences. And we should say, and non-constant first differences. So a linear relationship will have constant first differences. A quadratic will have non-constant first differences, but they will have constant second differences. That goes back to what we were talking about earlier when we were looking at 6.1. When we looked at a line, we saw that all of these are called your first finite differences or first differences. They all went over 1 up 2, over 1 up 2, over 1 up 2. If I went over 1, 2, 3, then I went up 6. So over 3, up 6. Whereas the parabola didn't do that. Over 1, up 1, over 1, up 2, over 2, up, over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 7. So it didn't work that way. These differences were not constant. These are constant. So, example 1. Make a table of values for y equals x squared plus 5x plus 4 going from negative 3 to 3. Negative 3, negative 2, negative 1. 0, 1, 2, 3. So it's going to be negative 3 squared plus 5 negative 3 plus 4. Negative 2 squared plus 5 negative 2 plus 4. Negative 1 squared plus 5 negative 1 plus 4. 0 squared plus 5 times 0, 5 times 0 plus 4. 1 squared plus 5 times 1 plus 4. 2 squared plus 5 times 2 plus 4. 3 squared plus 5 times 3 plus 4. This will be 9 positive, take away 15 plus 4. So 9 take away 15 plus 4 is negative 2. Make sure you can do this yourself. 4 negative 10 plus 4. 4 minus 10 plus 4. Wait a second, something's wrong. Let me do this again. This is 9, subtract 15 plus 4. Okay. This is 4, subtract 10 plus 4. All right. I didn't do anything wrong. Negative 1, so that will be 1. Take away 5 plus 4. 0 plus 0 plus 4. 1 plus 5 is 6, plus 4 is 10. 4 plus 10 is 14, plus 4 is 18. 9 plus 15 is 24, plus 4 is 28. Make a table of values from negative 8. Use this to determine if it is going to be quadratic or not. Okay, well, let's take a look at its first differences. Its first differences are going to be negative 2 subtract negative 2, which means that there is a difference of 0 between negative 2 and negative 2. 0 subtract negative 2 means that there's a difference of plus 2. 4 and 0, 4. 10 minus 4, 6. 18 minus 10, 8. 28 minus 18, 10. So remember what your first differences are. Your first differences are always this value minus the one before it. This value minus the one before it. As long as these go up by the same amount, it's this value minus the one before it. So we usually characterize that by y2 minus y1, meaning this one, subtract that one. This one, subtract that one. This one, subtract that one. So you have first finite differences that are not all the same. They're not all the same. So this is not linear, which means it's nonlinear. We don't know what it is, but right now it's nonlinear. So then what you do is you look at your second differences. Now what your second differences are is you take these values and do the same thing. Okay? So where you took the y value here and subtract it by the one before it, you're going to take the first difference value and subtract the one before it. So it's going to be 2 minus 0, which is 2. This will be 4 minus 2, so 4 minus 2, which is 2. This will be 6 minus 4, which is 2. This will be 8 minus 6, which is 2. This will be 10 minus 8, which is 2. So all the second differences are the same. So if the first differences are not the same, it's not linear, it's non-linear. But if the second differences are all the same and the first were not, then what you have is quadratic. And we just have to know that. That's not something that would make sense necessarily, but it is true. All quadratic equations have first finite differences that are the same. They're not the same, non-linear. But their second finite differences are all the same. That makes it quadratic. And if we were to do a quick sketch, just to make sure, excuse me, 1, 2, 3, negative 1, negative 2, negative 3. Now I've got to go from negative 2 all the way up to 28. That's pretty big. So maybe I'll go 5, 10, 15, 20, 5, 10, 15, 20, 25, and 30, and then that would be negative 5. So again, this is just a rough sketch to see what I'm getting, but if I try to plot this thing, that would be the x value, that would be the y value. So negative 3, negative 2 would be about here. Negative 2 and negative 2 would be about here. Negative 1 and 0 is here. 0 and 4 would be about here. 1 and 10 would be about here. 2 and 18 is about there. And 3 and 28 is way up here. So what we have here is that, and it looks like it's coming around and up here. So you'd have a vertex somewhere in this area. So we're getting a parabola shape with a vertex somewhere right in between there. But you don't need the graph. Don't need the graph at all. We could throw this into Desmos. Y equals x squared plus 4. Let's see if I have my phone here, and if I have Desmos real quick. So here's Desmos, and I'll just graph y equals, what was it? X squared. See, as soon as I put in the x squared, it goes to this U shape, plus 5x plus 4, and there you go. That is what we're looking at. Looks somewhat similar to what I have, and most importantly, we see that the first finite differences are not the same, therefore it's not linear, but the second finite differences are all the same, which gives us the parabola, which makes the equation quadratic. All right, let's see what the next examples are. I've got example 2. In this case, they're just giving me the table of values. So we'll take a look at the first finite differences. Let's call them FD for short. So remember how you do first finite differences. You make sure that these all are going up by the same amount. 1, 1, 1, 1. Yep. So these, you take y2 minus y1. So it's going to be -1, subtract -5. That'll be the first one. Then it'll be 3, -1. That'll be the second one. 7 minus 3, 11 minus 7, and 15 minus 11. Watching your algebra here, so negative and negative is a positive, so it's going to be 4. Negative and negative is a positive, so that's going to be 4. This is 4, this is 4, this is 4. All the first finite differences are the same. That means that this is linear. And again, we know that from grade 9, and that's going to be of the form y equals mx plus b. We know that for sure. Let's take a look at example 2, well, number 2b. So we're going to take a look at the first differences, making sure that these all go up by the same amount. They do. So y2 minus y1 is 4 minus 2, 8 minus 4, 16 minus 8, 32 minus 16, 64 minus 32. So this will be 2, this will be 4. As soon as that happens, I know that it's non-linear. 8, 16, 32. So we know that it's not all the same. So it's non-linear. Does that mean that it's quadratic? No, it does not. We're going to look at our second differences now. To be quadratic, all the second differences have to be the same. So 4 minus 2, 8 minus 4, 16 minus 8. I can already tell the second differences are not the same. So this is not quadratic. So what's the most you can say about this? The most we can say is that it is nonlinear. It's not quadratic, well, it's nonlinear and non-quadratic. Last one. Make sure that these are all going up by the same amount. Plus 1, plus 1, plus 1. Yep. So the first finite differences, I like using first, I think, instead of the f. It's going to be 1 minus 4. It's going to be 0 minus 1, 1 minus 0, 4 minus 1, 9 minus 4, -3, -1, 1, 3, 5. So it's not the same. So therefore it's non-linear. Second finite difference is -1 minus -3. It's going to be -1 plus 3, which is 2. 1 minus -1, which is 1 plus 1, which is 2. 3 minus 1, which is 2. 5 minus 3, which is 2. And you got to check all of them, because if one of them changes, then it's done. But since they are all the same, then we know that it is quadratic, which means that the equation that makes this table of values will look something like where a, b, and c are numbers, but a cannot equal 0 because we must have that x squared term. All right, ladies and gentlemen, that's it for me. We'll see you in a couple of days. And make sure to stop by any virtual classrooms to get some help if you need it.